Hello everyone, this video is about how to perform dimensional analysis. Dimensional analysis is the way we are going to do unit conversions. So in science, especially in chemistry, we often make measurements in the lab that we need to convert into a different quantity in order to use that to do an assortment of calculations. So dimensional analysis is the way we do it. So when I ask students to do dimensional analysis, I always just give 3 steps. There's 3 things that need to be done every time. So steps. So the 3 steps that you need is to identify the pathway. And what I mean by that is, where does the problem tell you to start and where is it asking you to go? After you've figured out like what the question is really asking, in that pathway, you need to identify any inequalities. So what are some things that you know are equal in that relationship that you have and where you're trying to go? What are the values that are equal? And the last step is to set up multiplication in a way that allows the units to cancel. Okay, so you want to set up these, they look like fractions, but they really are all equal to 1. Okay, so, and before we go on and do a couple examples, in this class, there are really a lot of prefixes in the metric system that you could measure and memorize, but I am going to only ask you to use 3 different ones. So you need to know the prefix kilo, which equals 1,000. Okay, so these are metric prefixes. Should have labeled this metric prefixes. So the 3 that you really need to know for this class are kilo is 1,000, centi is 1/100th, and milli means 1/1000th. So I'll use a couple examples over here. So 1 kilometer is really 1,000 meters. If you have 1 centimeter, that's 1/100th of a meter, and 1 millimeter is 1/1000th of a meter. For the last 2, students sometimes would rather set it up like this. You have 100 centimeters is equal to 1 meter, or you have 1,000 millimeters, that's equal to 1 meter. Okay, but both of those are true. It doesn't matter whether you want to describe it as 1/100th of a meter or 100 centimeters in 1 meter. Whatever equality you use, it's still equal. All right, so it's still going to be an equality. Sometimes people just prefer whole numbers to dealing with fractions or decimals. Okay, so we're going to follow those 3 steps for all different types of conversions. And if I'm thinking about sometimes I think it helps to identify categories of problems so that when you look at one, you can recognize what type of problem you're dealing with. So the first type of problem I have is if you are trying to convert one dimension, so in this case, the dimension is mass, 1 step. So grams to kilograms, we have an equality for that. So the first step asks you to identify the pathway. So for this question, we are going from grams into kilograms. 1 step, 1 dimension, 1 step. The second step for dimensional analysis asks you to identify equalities. So using the prefix kilo, we know that 1 kilogram is equal to 1,000 grams because of the prefix. And then the third step, this is the key. A lot of students are able to do these kinds of questions because they're good at math already, and they can use a proportion in their mind, and they understand how to set it up, and that's great. I really encourage you to learn how to use this process. It will be very valuable in chemistry and physics if you end up taking physics. And anytime you need to do multiple conversions, this process is way easier than setting up multiple different proportions. So just think this is the way to do it. So if you have 725 grams, we need to multiply this by some fraction. And the fraction is going to be equal to 1. Because these two things are equal, it doesn't matter which order you set them in. And what I mean by that is, you could put the 1,000 grams on the top or the 1,000 grams on the bottom. And the quantity that you multiply this by doesn't change because this is always equal to 1. But we want to put the 1,000 grams on the bottom because that allows the units of grams to cancel. So what we're doing is we're multiplying this fraction. When the grams cancel, now you multiply across the top. 725 times 1 is 725. And the only units that remain on the top are kilograms. And then you multiply across the bottom. So 1 times 1,000 is 1,000. And there are no units left on the bottom. The grams have already canceled. So then you use your calculator or you do this math in your head. 725 divided by 1,000 is 0.725 kilograms. So these 3 steps, no matter how difficult the problem is, if you're doing a conversion, you can do all of these to set up your math problem as multiplication of fractions. Okay, the next step that is slightly more complicated is the same dimension, but if you have to do it multiple times. So in this example, it asks us to convert 2,650 centimeters into kilometers. So our pathway is centimeters to kilometers, but we might not know the conversion for that by itself. So centimeters to kilometers can be broken down into a couple steps, centimeters to meters, and then meters to kilometers. That's my other cat, Louie. So in this example, we have multiple steps. We need to convert centimeters to meters, and then we're going to convert meters to kilometers. So every time you have one of these steps, every time you have like a point in this pathway, you will be able to find an equality for those two things. So we need an equality between centimeters and meters. And from the previous slide, we know that there are 100 centimeters in 1 meter. And then we also need an equality for meters to kilometers. So if you have 1 kilometer, we know that that is 1,000 meters. So this equality is for this step, and this equality is for the second step. Okay? The third example asks us to set up units to cancel. So multiply in a way that's going to cancel the units. So the number we're starting with is 2,650 centimeters. You can put it over 1 because any number over 1 is itself. And it makes it, I think it makes it look nicer. It's a bunch of fractions. Okay, so 2,650 centimeters need to be converted to meters. So we're going to use this conversion factor set up in a way that allows you to cancel centimeters. And then separately, the next problem is to set it up so that you cancel meters. So the 1,000 meters goes on the bottom, and the 1 kilometer goes on the top. Okay, so from here, you are able to cancel units. So centimeters cancel. You're able to cancel meters. And now the only units left are the kilometers. So we multiply across the top. So 2,650 times 1 times 1 is 2,650. And the only units remaining are the kilometers. And then you multiply across the bottom. 100 times 1,000 is 100,000. And so, if you did this math on your own, either in your head or on your calculator, you know that you need to move it 5 points. And you would end up with the number 0.0265 kilometers. Okay, so this last zero, one quick comment about sig figs, this last zero right here, it's not considered significant. So when you write it in the larger unit, you don't need to include it. Okay, so you can see that you have multiple steps here, but it's still only one dimension. It's still just length, some version of like distance. The next level up, once you level up one more time, is if you are trying to look at multiple dimensions. So like consider an example where you have, oh, I should have put values in here. Consider an example where you have 12 liters per hour. So the question is asking you to convert liters per hour into liters per day. So okay, so if this was the problem, the first step we do is the pathway. So we have liters per hour into liters per day. So the thing that is being converted has to be in the denominator in this case. So this is more than one dimension. This is a volume, and down here you have a time. So those are the dimensions that are being considered. And in your equalities, we have to come up with an equality between hours and days. So so in the second step, 24 hours equals 1 day. Okay, lastly, you just set it up so that units will cancel. So if you have 12 liters per hour, we need to use this conversion factor in a way that allows hours to cancel. So there are 24 hours, so the hour goes on top, and 1 day. So if you did this math quickly on your calculator, 12 times 24 is 264. Is that true? Let me just, I don't want to be on recording as wrong. 288, that would have been wrong. 288. You can see that the hours have canceled. 288. So the only units remaining are liters on the top, and the only units remaining on the bottom are days. Okay, so if you need to convert something in the denominator,